All right, today's lesson is going to be about writing inequality statements using rational numbers. So we don't have variables this time, but we have rational numbers, and we need to write the inequality statement using the greater than, less than symbols. All right, let's take a look at our first example. It says, write one inequality statement to show the relationship between the following shoe sizes, 10.5, 8, and 9. Okay, we want one inequality statement. I could say that 10.5 is greater than 8. I could say that 8 is less than 9, that 9 is less than 10.5, and so forth. But I want one inequality statement. When we do it, we want to put them in order. This time it tells us from least to greatest. So if I was going to put these numbers in order, they are all positive numbers. So I could start with the least number to the greatest. So I'm going to kind of put them in order first. So 8, 9, and 10.5. All right, between each of them, I have to show the relationship between the numbers. So I'm going to look here, 8 and 9. 8 is less than 9. So I'm going to put the less than symbol. 9 is less than 10.5. So I'm going to put the less than symbol. This is showing one inequality statement showing the relationship between those numbers. I'm going to use those same numbers, and I'm now going to go from greatest to least. So I'm going to put them in order first, from greatest to least, leaving space for my numbers, or for my symbols. I'm going to look at the first two. 10.5 is greater than 9. 9 is greater than 8. Simple enough? Okay, let's move on. We have another example here. It says Mary is comparing rainfall totals for May, June, and July. The data is reflected in the table below. Here's her table. Fill in the blanks below to create inequality statements that compare the changes in total rainfall for each month, the rightmost column of the table. So we're going to look at the changes here. So we're going to compare these changes the same way we just did on our last one. Okay, so our first problem asks us to write one inequality, just like we did in the last problem, to order the changes in total rainfall. Okay, so we're going to put them in order from least to greatest. So looking at our numbers, we have negative 1.4, 0.3, and 0.5. Well, I know that there's one negative number. Negative is to the left of 0, so that's our least number. So my least number is going to be negative 1.4. Between the next two numbers, I have 0.3 and 0.5. If I think of absolute value, I know that 0.5 is farthest from 0 to the right. That makes it my largest number. So my second number is 0.3. Again, I'm leaving space for my greater than or less than sign. I mean 0.5 is my greatest number. Least to greatest. Looking here, negative 1.4, because it's negative, it is less than 0.3. 0.3 is less than 0.5. Okay, from greatest to least. What happens to my numbers? Well, from greatest, I know that 0.5 is the greatest. It kind of flips around. I know that negative 1.4 was my least, so it's going to be on this side. So I'm going to put them in order, just the opposite, basically. All right, now I'm looking at the first two numbers. I know that 0.5 is greater than 0.3. I know that 0.3 is greater than negative 1.4. You notice how I cover up one of the numbers to compare two of them, and then compare the other ones. Makes it much easier for my brain to just see two numbers. In this case, does the greatest number indicate the greatest change in rainfall? My answer is no, and here's how I know. the change in rainfall has to do with the greatest absolute value. The absolute value of negative 1.4 is 1.4, positive 1.4. So there was an inch 1.4 inches change in May. There's only a 3/10 of an inch of change in June, and a half an inch of change in July. This is the most change. It's to the negative, but it is the most change, so the greatest change. So I could put that here in written words, but I will save you that, and I will create just a quick little video. We are done for today's lesson. If you have any questions, you know the drill. Please put them in your ISN.